Question 5 is another electricity question, and again starts with a circuit symbol you have to learn. This one's a bit more advanced than the switch, and the three options you get are very similar, so you really have to know which one it is, and it's the middle one, the light-dependent resistor, that this symbol represents. The next part of the question asks you to describe the changes from this graph. The graph shows how the resistance of the LDR changes with light intensity. So describe in detail how the resistance of the LDR changes as the light intensity increases from 0 to 50 lux. And there are 3 marks here. So let's look in detail at the mark scheme and at this description. Let's start at the bottom. It says an answer that says resistance falls as intensity increases gains 2 marks. So that's describing a very general trend in the graph. It doesn't give us any specific information about the curve. So if you see a 3-mark question for describing a graph, you need to include more detail than that. It does say, though, that this may be combined with one of the bullet point marks for full credit. The easiest ones here are to look at the start and the end of the graph. So at 0 light intensity, what's the resistance? And you can see here it starts at 500 kilo ohms. And at the end of the graph, where we have 50 lux, it has gone down to 10 kilo ohms. So there's very easy points that you can get there. Start and the end, just read the values off the graph. And there are several other things here. Resistance falls rapidly as intensity increases from 0. That shows that the big drop off to start with. And things like resistance drops very little or levels out between 20 and 50. So more detail than just the decrease. So 5C part 1. Complete the following sentence by drawing a ring around the correct line in the box. A decrease in the light intensity of light on the LDR will either decrease, not change, or increase the reading on the ammeter. Now, we've got to think carefully about this. So, a decrease in the light intensity is going to do what to the resistance is our first question. So again, we look at the graph. So if we imagine starting off at high light intensity and decreasing light intensity, that means the resistance is going to get bigger. As we go down towards the low end of the graph, the low light intensity end of the graph, the resistance gets higher. And if resistance gets higher, it is harder for current to flow around the circuit here. If it's harder for current to flow, the current will decrease. So there is our answer. A decrease in the light intensity of the LDR will decrease the reading on the ammeter. And we've just talked about the reason. Give the reason for that previous question is the fact that the resistance increases. And the final part is talking about an application of this circuit. So an LDR can be used to switch a circuit on and off automatically. In which one of the following would an LDR be used? Well, here you just have to look at the context that we've been talking about. All the information in the question has been about light intensity. A circuit to switch on central heating would have to be measuring temperature, so this circuit doesn't do that. And a circuit to switch on a water sprinkler when the soil in the greenhouse is dry would have to be measuring humidity or moisture content, and this circuit doesn't do that. What this circuit does is to measure light intensity, so it should be used to switch on security lighting when it gets dark, the middle option there.